Hello everyone and welcome to join our webinar, Modern Microcontroller Application Development with GUIs. My name is Vera and I will be your moderator. Today we have here our GUIs experts, our Senior Solution Architect Cedric Ledillau and our Senior Technical Artist Arnaud Armengaud presenting. Before I hand over to our experts, I have a few things to mention. First of all, we would love to hear from you during today's presentation, so please, if you have any questions, just use the Q&A button and our experts will be covering those in the end of the session. This webinar will be recorded and you will receive a copy of it delivered to your email account later after this session. But now over to our experts. Cedric and Arnaud, the stage is yours.
Thank you, Vera. So yes, it's me, Arnaud Armengaud, your technical artist for this session. Let me explain how to create HMI on MCU. First, why include Design Studio on the global Qt environment? This global workflow, it's first to create better communication between developer and designer, to allow for the designer to keep the hand on all the process of the design, and faster, and of course, it's a faster time to market. So quickly, what's the current designer developer workflow? It was mine, it's probably on yours. As a designer, I create on Figma, Photoshop, it could be Sketch or XD. I create my screens and I exchange with the developer team and produce some specification for the developer to create from scratch the design. Because all I can share with the developer, it could be some graphical assets, but mainly all the HMI is created from scratch by the developers. And for check what happened on the final devices, I need to wait for the development team to deploy after to ask for changements, because the results on the final devices are never, of course, the same on my desktop. So this process needs a lot of time, a lot of exchanges can create some tension, and it's not the best solution. Why? Because the difference of the tools used by, on one side, designer, and on one other side, development, are not the same. It's create like a wall between these two teams, and so for the time to market, it's not a good thing, and for the global synergy, it's not a good thing. That's why we create and we propose our solution for design on MPU, and especially on the session for MCU. So that's our solution. First, designer will create all the screen on one of these four designer soft: Photoshop, Sketch, Figma, and XD. This cover 95% of the usage of the designer. There are no limitation to create a very high quality of screen. And for this designer soft, we propose you a plugin, very easy to install, the Qt Bridge. So with the Qt Bridge, you push the blue button, export a file. Let's go on Design Studio. Your designer, you import your file and recreate it on one click on a perfect pixel way on Design Studio. So first, for the developer, no need to recreate the position of all the assets shared by the designer. On Design Studio, the designer will create animation and transition between the different screen, create some states for the button, and all the effect and animation which needed for high quality HMI. The main value of our soft, our Design Studio soft, it's when you create an animation on the designer way of use, you generate some QML. It's very important because when I work on Design Studio, I generate some code. So for the development on the perfect way, they absolutely not have to work on the design. You just give your code at the end, and the developer could just on the backend plug the value needed on your HMI. Of course, designer and developer could work together. Developer could help the designer for the question, hard question, or for the complex HMI, because the developer work on a language, very easy language. You have to know that QML is a declarative language. That means, as a designer, I can understand what's happened on the QML. I will show you. A very important point that for the designer to allow to deploy, I mean, to check what happened directly on the final devices. With boot to Qt, I can deploy on an MCU or other devices, and no need to wait for the development to deploy on this device. I can do it myself. So I can change the direction or make all changement I need for at the end have my perfect design. Now let's go on Photoshop. I choose Photoshop for this demo, but the process is exactly the same on Sketch, Figma, and XD. Let's go. We are now on Photoshop. You can retrieve all the group of layer, all the artboard. I create artboard for the different button, for the menu, for my button with different state inside my button. The concept, the process is easier on Figma and XD, especially because our tools on Design Studio is built on the logic of components. So I create my different component here, and let's show you the Qt bridge. My extension Qt bridge is this tool. My main task as a designer is to choose for each of my layer and my group how I want to export it. I can export it as a component. Component is a QML file. I can export it as a child for the main of my assets, but I can choose to merge it to make it simplest on Design Studio, or to skip it. So not have to build or to create a special file, especially to export. You can use the same file to create your interface and export. It's my main task. Of course, be careful of the naming, because at the end, remember that we are animate your HMI and generate some code. And maybe as a designer, you don't know, but the naming is important on the code because it's a language. I just ask to press export. Let me just show you what happened on the export file. I create and generate a lot of PNG. It depends on the complexity, of course, of your HMI. The number is not huge because I merge a lot of, especially on the background, a lot of layer and a metadata file. This metadata file include all the information to recreate immediately my screen on Design Studio. Now, let's go on Design Studio. We are now on Design Studio. On your left, we can retrieve all the different components I already created on Photoshop, and my navigator is the same navigator than on Photoshop, for example, with my other component and my different group and layer. But let's run and check what we can do now. I choose to create 3 pages and slide it. Here, an animation with a toggle button. On the central page, different kind of button with to change value with different states, a slider with change of color according to the position, and a central element. Let's check together how animate these central elements. What I want is to change the central value according to the position of my handler, and my needle, this graphical element, change the position according to the value. Let's check first into a gauge. I already created this component. We're on the component. Just let's background to have a good view of what happened. What I want now, I want to change a text and a position and create an animation of the assets according to one property. I will first create this property and choose for name value. It's on my right. I just give this name and choose to not use some decimals on this value. Okay, now I have my text and my needle. Let's start with the text. For the text, where is my text? It's here. So let's bind it. What I want. We're on the gauge components. So I select gauge and I want the value of the gauge is dependent of course, the property I created, value. Let's enter. Okay, it's normal. By default, the value is on 0. And now I will create the animation with a timeline. It's, I hope, very comfortable for the designer to use the timeline. The timeline creates an animation between one first point and one last point. Based on the frame, it creates automatically what happened between these two states. So I create a timeline and I ask to the timeline to depend of the property I already created. It was value. I just enter on expression binding value. I choose only 100 frame because my value is from 0 to 100. So it will be easier, of course, to have 100 frame. Okay. So I have 100 frame. At the frame 1, I want the value are 0, and so my needle are in front of 0. I choose my needle, and I want for animation a rotation. So I first enter the value, I mean the position of my needle on 0, and on the first frame, I insert my keyframe. Let's go on my last frame, enter the value of the position of this last frame, and again, insert a keyframe. Now, let's back on my main screen for the third test, which is to check if when I select the gauge, I created the property, the value is here. I just have to enter an example, 50, and check yes, if the text move and is the needle move too. Okay, so I just want now to link the position of my handler and the value. So let's again select the gauge and the value. I want to bind this value on my slider. I'm going to give this information that my slider handle will be linked to my slider value. And press enter. Now, let's check what happened. If I move my handler of my slider, the value change and the position of my needle change. I think my parts of the job are done. So I let the hand to Cedric. Before, of course, I'm going to push on Git my project for Cedric to continue to work on it. Thanks a lot.
Great. Thank you, Arnaud. My name is Cedric Ledilo. I'm a senior solution architect at the Qt company. Today, I will show you the value proposition for Qt for MCU from behind the scene. You have seen in the first part of this presentation that Qt for MCU allows you to design modern user interface similar to IM embedded and desktop systems. It manages properties, signals, and slots, which are the basis for UI interactivity. Qt for MCU also supports multiple languages and comes with multiple examples and demos, where demos are far closer to real product. Unlike the Qt framework, Qt for MCU optimizes your code at compile time. There is no script engine, so the QML code is compiled through C++. You can also give hints to CMake to choose for compression, cache, RAM and flash location preferences for your application assets. Qt for MCU also comes with dynamic and static font engines, Unicode engines. The dynamic font engine uses monotype Spark engine to render the pre-computed TrueType fonts, whilst on the other end, the static font engine grabs the glyphs needed for your application from your code. Qt for MCU also brings RTOS support for several platforms, which is not shown in this presentation. The porting interface and the Qt Ultralight are recompilable. All source code of MCU and the tooling are delivered to ensure the base support. The latest version is 2.0 from the 21st December last year. A migration guide is also provided to help you for your former project to migrate to the 2.0 version. I will show you a bit during the presentation. For the next steps, I will use the Qt Creator plus the BSP to demonstrate some hardware usage from the Qt for MCU project. Let's switch to Qt Creator. In order to migrate the Lightblue Interactive project, we'll use two other projects. We have the minimal, and then the one created by Design Studio. We also need the migration documentation on the website, the guide. Then we need to start with the CMake changes. From the experience I got to migrate to the 2.0, there is, in my project, the font folders that are now font list. We have also the module name, which are changed a bit for 2.0. And we have also the dependency when we include the libraries, source library. Let's migrate the project. So the minimal project, it's too minimal for what we need. We will use the project created by Design Studio. Okay. So from the project from Design Studio, I will grab the libraries. Okay. You can see that dependency is set for the project 2.0. Sorry. We have to catch also the font folders. Okay. And of course, we need to set for the correct project. And remove all information related to fonts. And here we need also OTF files. So to set the correct project. Good. Now remove this one, which is already handled with the block I copied from the Design Studio project. Okay, perfect. There is also another migration to take care of. It's with the main.cpp file. We need also to initialize the platform. Let's see it running. It's a project. Nice. So now I will open the Thermo project, Thermo demo, from Qt4MCU demo folder. From there, I want to grab the front engine configuration, which is not included already by the project from Arno, neither by the project generated by Design Studio. Okay, so here we configure if we want the static front engine or dynamic one. Dynamic one is a monospace Spark front engine. I will pick some lines from this file. Let's see if it's okay. I finished. Okay, we should be ready for live testing now. Select the correct project, compile. Again, Okay, let's go and check this application. German, Japanese. Plus, minus, fine. Now let's see how to give hints to optimize your project. First, you will need to get the documentation for the resource. Optimization hints are in the CMake properties. By default, all resource files, all resource images are set with compression, but I will use optimize for rotation for the needle of the project, of this project. Let's pick this one. Okay. Copy it. Yeah. Okay. I will set resource optimize for rotation. And I guess in assets, yes, it's needle MCU. Let's go back to the project view. Okay. Set needle MCU.png. Okay. So we have seen that there is many different optimization or hints to set for your application. It's really specific to your application, to your needs. Now let's see some figures about the project. Okay, so the minimal project uses space size of 160 kilobytes. The mini Qt Design Studio 3 use a bit more because it embeds the default controls. And the light blue with static fonts consume 7.7 megabytes, and the light blue with dynamic fonts is using a bit less than 10 megabytes. I will arrange my environment for the hardware part. So let's see. Here we are for this hardware part. I will base my development on this mini car based on a Raspberry Pi. So there is a Raspberry Pi inside driving the electronics of the vehicle. I plug this mini car to a Renesas evolution board, evolution kit, which is based on RSX M3 from Renesas. And specifically, I reused one servo here for the direction of the vehicle and plug it to the board. Here I have an extension kit to have the capability to plug several servos. I also plugged a relay here, and we will see how to drive them simply on top of Qt for MCU without touching the Qt Ultra libraries. Okay, so the goal is to use this kind of Architecture. We have five modules, 5 base modules for digital output, PWM, digital input, analog input, and analog output. And based on these 5 modules, we can derive some functionalities that are useful for us. Okay, let's see in the code how to do this. Okay. So for this part, I already ported the code to Qt for MCU 2.0, and I would like to show you one piece that I've missed in the previous project, as it wasn't based on the main.cpp file. And in this file, you have also to add init hardware for the Qt for MCU 2.0. Okay. Starting from the makefile, I base my, let's start from the top. Okay. From top to bottom, let's see what we have in this makefile. We have the project definition, some libraries for previous version of Qt Ultralight. We have the new font definition, the resources plus QML files. Here we have the new Qt Ultralight libraries plus the dependency. This hardware board definition. Here we are manipulating some strings to guess correct board, OS, and board family. And according to this definition, we can define what are the BSP files we need for our project. So here, this is the Renesas board, RS6 M3, and we need those folders from the BSP to be able to use hardware modules. So the ones are for STM32. And we are at the bottom of the file. Here we have the board specific definition. And lastly, the OS specific main.cpp file. So going to the folders, we can see we have only the RS6 files and not the STM32. This is due to CMake filtering and showing only the file we need. So board. The board has a specific definition for all the modules, all the base modules that we have seen in the slide. This one is the implementation of these modules. It's based on the BSP files for the demonstration, for the demo files from Renesas. The board. We can see the board definition here with all the submodules included. And one trick for Qt for MCU, or for Qt also, is the use of Qt Ultralight singleton for this class. So this allows us to use this class and the functions directly from the QML files. And I will show you this. Okay. So we can use directly from the QML so the class hardware board and use the functions included in this class. So maybe we can plug the board and see what it does. Okay, plug the board. Starting. Flash board. Should be quite quick. Okay. Nice. Now we have this interface, this UI, and from there I can drive my servo directly with Qt for MCU. So this is possible because the PWM needed for the servo is not a high-end protocol stack to use. It's a simple module. So the PWM, also the relay is connected here. The relay is breaking the circuit for this USB module. Okay, stop it now. Okay, so you've seen that it's quite simple to build something, some hardware stack on top of Qt for MCU without modifying the Qt Ultralight and neither the porting interface that is required if you need some specific functions. Maybe we can wrap up this hardware part and going back to this this slide. We can see that the hardware board is heavily using the other modules and propose a QML interface. So to wrap up the webinar, we have seen how the Qt tools are friendly with designers and how to export your project from Photoshop to Design Studio. Arnaud showed you how to import and animate your UI in Design Studio. Also, I showed you how to port your project from one version to the Qt for MCU 2.0. It's really essential for your work to stick to the latest version. I showed you also how to deal with font engines and what are the final size of your projects. And finally, I showed you how to manage your hardware. I mean, simple hardware with IOs, with PWM. What function is in the SOC, in this system on chip, and not the high-end stacks like TCP/IP or USB. So for simple project, it's totally doable without modifying the Qt for MCU libraries or the porting interface. It's now time for the question. we'll be happy to answer them. Thank you for your attention.